all affordable to general machine shops. This is what we're saying, Richard.
That's the plan. Yeah, this is now, on that level where people thought that Okuma maybe were out of their price range, but realistically they're not.
Hello and welcome to another MTD podcast. This one's being filmed here at NCMT in Coventry. The subject today, as you'll probably have guessed, is this Okuma machine and the Okuma range of machine tools, supplied of course by NCMT. I'm with Richard Turner, who is going to be my guest on today's podcast. Richard, thanks for allowing us here to NCMT and to be able to produce this podcast. Perhaps for those, and I'm sure there's not many, that don't know you, can you just introduce yourself to our audience?
Yeah, so my name is Richard Turner. I'm the General Manager of Okuma Products here at NCMT, so looking after our pre-sales department, any questions that come in for anything Okuma related. I've been here now for 16 years.
And we're going to put you to the test on some of those things over the course of the next half an hour. So coming up in this podcast, firstly, we're going to learn about Okuma in general, the range. We're then going to touch on the Genos range within that Okuma brand, and then we'll specifically talk about the 5-axis behind us here. So, Richard, let's talk about Okuma. Maybe you could give us a little bit of the history, and there will be people who listen and watch what we do at MTD. They will know of Okuma. They will have seen the machines in action. But it would be good to get a little bit of a history and your opinion on what this brand is.
Yeah, Okuma Machine Tools, I think if we go back, people sort of always recognise Okuma as being a lathe manufacturer. Obviously, that's not the case nowadays. They produce a wide variety of machine tools. But even going further back, it started out, Mr. Okuma himself started out by building a noodle making machine. So quite something different. As in making noodles.
Pot noodles.
Yeah, noodles that you would consume. He had a noodle making machine. From that progressed into making other different bits of machinery, which then progressed on to making lathes. Started out as obviously manual lathes. That progressed on to CNC. And then moving forward, machining centres and lots more. Mill turns as you see today, 5-axis machining centres such as the one behind us.
And this all started over 100 years ago now, didn't it?
Yes.
1918, I believe.
1918 was when Okuma Machinery Works was founded. Yeah.
Okay, now, what would you, in your opinion, think that our audience perceive Okuma as? How do you think they're seen?
I think Okuma is a brand that people think is a high-end brand of machine tool, which, okay, yes, they're not wrong. But like we're here today with this machine behind us, we're trying to get people aware of all the other products that Okuma can offer. And it's not just the high-end machine tools. We can offer a wide-ranging machine, for instance, such as the one behind us. So it'll cover subcontracting environments.
You mentioned to me as well, in preparation for this podcast, about the double column machines that Okuma supply. Apparently in Japan they sell more than anybody else, or it's their best-selling machine. Is that right?
Yeah, so a big portion of their market is double column machining centres. Don't get me wrong, a majority of those go in Japan for automotive industry, making die and mould sort of industry. So very large double column machines. But that's why Okuma always call themselves the mother machine, because they produce other machine tools. If you go into some other machine tool factories, there will be Okumas in there producing those machine tools.
One machine that always stands out for me, and I love seeing in action, is the Multus machine. There's actually one over there sold, so we're not going to see it in action today. But that's one of your sort of flagship premium multitasking machines, isn't it? It's quite something, that.
Yeah, I think, as I said, I've been here for 16 years. When I started, the initial Multuses then were sort of quite new. They've progressed a bit since that point. But going back then as well, was also lathes were quite prominent still in the market. But now we're seeing that change, and it seems to be that the mill turns are right up there with the rest of them now. So that seems to be a choice over just the standard lathe.
Okay, now if you have got any questions or anything you want to ask Richard or his team, you can contact them via the NCMT website. Now, NCMT, it's not just the only product you sell here. Let's just have 30 seconds on the business itself here, which is selling and supported.
Yeah, so we obviously sell the Okuma machine tools. Alongside that, we have a wide range of Makino machine tools. Again, very high end. They focus more on specific sectors, so they'll make machines for the aerospace sector, medical sector, so they'll have very specific machines built to suit very specific sectors. Alongside that, we also sell blue photon products. So that is a work holding solution that can use a UV cured adhesive for holding components in a free state, so you're not applying clamping forces to a component.
Okay, and we're going to see this machine in action later. There will be a video on our YouTube channel of that happening. So if you're on our YouTube channel or you're somewhere else, go to YouTube and you'll be able to see this this particular Genos 460 in action. We'll also be talking to Richard about the demonstration that it's performing. So on that point, let's talk about the Genos range then. What is it? Why has it been introduced, and who's it for?
It started out a few years back now. So Okuma realised they needed to try and make a more cost-effective solution, but still keep everything Okuma, if you know what I mean. So they're keeping everything as rigid and as accurate as it can be, but offer a solution to customers that were looking to try and break into that Okuma market and try and get into that area. So the Genos stands for Global Economic #1 Standard, which is what the Genos stands for. So they introduced these, and we have a range of lathes. We have a range of 3-axis vertical machining centres, and also the 5-axis machining centres. Our 5-axis machining centres, we have the Genos M460, which is behind us. New to the market, which is coming soon, or soon available to order, is the M560, which is the larger version.
I saw that one at IMTS actually.
Great machine. So it's a great addition to the lineup.
Which is just a bit bigger than the one we see behind us here, isn't it? With a couple of other features on it. Yeah.
And both of our 5-axis machines are actual true built Japanese machine tools. So they are actually still built in Japan, all to the Japanese standards. The lathe machines, they are to the Japanese standards. So everything you would expect from the flagship LB range, you still get on the Genos range.
So it sounds to me like you've kind of created machines around what general engineering needs. So you've selected models, 3-axis machining centres, 5-axis turning centres with Y-axis driven tools and sub-spindles. They are kind of, I don't want to say the word pigeonhole because that puts them into a small bracket, but it's a big bracket, but it is a machine that is in demand within that market, isn't it?
Yeah, definitely. I think it is. We've seen ourselves in the UK that it is a demand, because we do seem to sell quite a few of the Genos range machines, whether it is the lathe or the machining centre. They have been quite popular. But it's more about what the technology you can get on there. Don't get me wrong, the reason they can offer them at the price they can offer them is because they keep them at a limited list of options. Whereas an LB, for instance, on the LB range, there is an extensive list of options. So there's lots of things you can add or take off, whereas that is not available on the Genos range. But you are getting a very good machine, very accurate, very rigid. Yeah. Okay,
so we're now talking about the Genos range, and what we're going to do now is dig into some of the areas that you're offering as standard on this machine, as well as your other Okuma products, which people might be surprised at. They may not know, and they need to know because it can be a benefit when you're machining. So perhaps let's talk about something that's very pertinent to the current economic climate, about making these machines as efficient as possible. Every time that spindle's cutting a bit of metal, it's costing money, Richard, and everybody knows that. So how do Okuma address this and try to reduce the cost of machining?
Yeah, well, Okuma have been doing this now for a little while. There's some things that already exist on the machine that are adding to this. So it's things such as the thermo-friendly concept. So that's one item. With that thermo-friendly concept, because the machine has been designed and constructed in such a way that it doesn't need a temperature control environment, that is one cost saving, because you're not having to put it into an air-conditioned room or an air-conditioned factory. You don't have to have that expense of air conditioning. So that's one aspect that's always been there for quite some time now on our machines. So that's the first one.
And is there a way you could quantify how much of a saving that could possibly be for somebody then?
Yeah, so Okuma have done some tests already, as opposed to a machine with the thermo-friendly concept turned off versus with it on. And when it's off, they said, okay, well, the cost of a temperature-controlled room to keep it stable costs whatever it costs. And they worked it out that it was a 20% saving in power usage for that machine.
That's quite substantial.
Yeah.
Okay, what else? What else do you offer?
So alongside that then, so all Okuma's built now since October this year, they're now off this power regeneration system. So things like when the axis decelerate or the spindle decelerates, any power that is generated from that is then put back into the system to be reused on the machine. So that's something new that Okuma have been adding to the machines, and that's across the range again.
Doesn't matter whether it's a Genos machine or another. Right.
No, it's across the range. So that is then adding the power back into the machine. So again, saving more costs. So that's one of the other elements that Okuma have considered, and it's now applied to.
Okay. Any other areas when it comes to the economics?
So there is another one that's optional. This is a new option. It's called Eco Hydraulics. The standard hydraulic system on the machine is run by a pump, so it's an on or an off, and it's running at its power. Now, the Eco Hydraulics, they can run a servo-driven hydraulic unit, so it can increase or decrease the pump loads, so basically increasing or decreasing the power usage, depending on the demand on the machine. So again, saving more energy.
Okay, now if you took all of these and anything else that you may offer on it, the question people probably listening or watching are going to be going, okay, so what's that mean to my back pocket? This machine costs me, and I'm sticking my finger in the air here, £30 a day to run, whatever it might be. How much is it going to cost me now if I utilise these features? Is there any way you can give us some idea? Okuma
have done a study where they've looked at a machine without all of these elements they've been adding to the machine, and as a rough sort of guide, they believe a 45% saving can be made when all of these elements are applied into there. Okay, take into account that a customer wouldn't have or would have air conditioning or not. So that is
45%, so it could be
45%,
half.
yes.
So you could look at, if energy costs double, by having a machine like this, you're still going to be paying almost about the same then as you would now.
For running costs, yes.
For running costs.
Yeah.
That's massively important. Okay, so if you've just picked us up on this podcast, we're actually talking about Okuma, but not just Okuma, we're talking about the Okuma Genos range here with Richard Turner, and that's what we're really going to dive into now, Richard. This 460, let's talk about this machine that's behind us. It's available here from stock, which is important because you're bringing these through regularly, aren't you? Not just the 5-axis, but the 3-axis and the lathe as well, because that's quite crucial in the market you're looking to service, isn't it? People want something tomorrow.
Yes, and that's, I think we're finding nowadays, is people want things quicker, and unfortunately the global state at the minute with demand is quite high, so there is a lot of stock shortages, but with Okuma they've sort of got the finger on the pulse, and we seem to have a reasonable amount of stock level. It's not bursting at the seams, don't get me wrong, but we have a reasonable amount to cover a wide range of stock.
And when we came here a few weeks ago, there was 4 or 5 machines dotted around here, which aren't here now. So you must have sold them.
Yeah,
they've been stolen, one of the two.
There is a flow of machines, that they are coming in, and again, they are going out because we are selling these machines.
Good. Now let's talk about the 460. Give us a quick rundown of what this model is. There is a video on our YouTube channel of it in action. Just tell us about this particular model and its features and specification.
Okay. Yeah, so this machine is a 5-axis vertical machining centre, has a trunnion type 5-axis vertical, a 400 size table, but we can swing a diameter of 600 with a part length of up to 400. The spindle is a 15,000 RPM spindle, 22 kilowatts, 200 Newton meters, a 48 tool magazine. We have thermo-friendly concept as standard on this machine. We can also offer the 5-axis auto tuning as standard on this machine.
Okay, now what do you have to look for then? What do Okuma look for, and what do you advise them to look for when you're looking to try and get a machine of this nature, a 5-axis machine, into a general engineering machine shop? You mentioned 48 tools. Yeah. That's important, more tools. You talk about a spindle there, 15,000 RPM, but is that going to cover most applications? Where are the areas you really have to get right?
Yeah, and that's what this Okuma machine is all about. It's about being wide-ranging, which is why they call it the wide-ranging spindle on the machine, is because it covers a wide aspect of materials. So the 15,000 spindle with the 22 kilowatts covers a wide range of materials. So you can do aluminium, you can do titanium. It's not focused directly at one specific type of sector or material type. So it's covering a wide aspect. So again, subcontractor environments, this would suit really well.
And that's one area. What about actually how the machine's made, and the stacking of the axes and the way each one moves?
Yeah.
Do those things matter?
They do, yeah, definitely. 100% they matter. There's a lot of things that matter about the design of the machine. So the axis on this machine, the y-axis is on the bottom, where the X and the Z is at the top, so we're not stacking everything where the weight of the component's sitting. So it's trying to limit that, so we're not having any influence on the axis and where we're changing the weight. So where it's heavy, then light.
So if you add a heavy part, you want to minimise the amount of movement on the axes with carrying that part.
If you had multiple axes stacked upon each other, yes. So that hence the reason why it's only one axis on the bottom and the other two are on the top.
And what about the direction of this table? So here we see it in front of us, left to right. Some people have them the other way around, don't they? Are these things that you have to take into account? And if so, what's the differences?
They are what you have to take into account. The ones that are the other way around and face you, they're normally single sides main supported. Sometimes they have a small support at the front. But this way now we've got here is about rigidity. Both sides are very, very bulky rigidity.
Is there a way that table's made that might be different to somebody else? Is there a way the table is driven that might be different to somebody else?
The drive on this table, it uses a hypoid gear drive. So it's not a direct drive directly from the bottom, but there are reasons for this hypoid gear driven box, and that's to do with accuracy and repeatability again. So that type of gearing mechanism is a lot more accurate than other types, direct bevel gears, etc.
And how are you going to get the swarf out of this as well? Are these things that, you don't want to get little traps in the machine, and you've got to get the wash guns working or the wash down working correctly? Little things, but they're important.
Yeah, they are important. They're always important. So inside the machine there are coil augers that drive it to the back. From the back we then specify whatever swarf conveyor is required for the material type. So it could be a drag conveyor, could be a hinge conveyor, could be a dual conveyor.
Okay, and what about your tool changer yourself? You say 48 tools. Is there any options to extend that? Is that a standard? Where is it accessed? Is it out of the working area?
Yeah, so the access to that is at the front of the machine where the operator will be standing. It is fixed at 48, hence the reason this Genos range, as I was saying earlier, about limitations on options. So that's one of the things that is fixed. You can't change that, you can't make it bigger.
And when you say that, so we're talking about standards there. Is there things on this machine on standard that people need to know? Because if you're watching this machine is available from stock here. It can be seen in action here in Coventry, as we're going to see today, and we're going to have a video on our YouTube channel of this actually cutting. Is there things like through spindle coolant on here that come as standard? The linear scales, all of these things, is that part of what this package would include?
So there are two different levels to it. So there's the basic standard package, and then there's the high level package. So they are very similar, if I'm being honest. The addition of the high level one, it adds the scales and it adds the 5-axis auto tuning. They're the differences between the two. But there's lots of things, as you mentioned there, about through spindle coolant. Yes, that's standard. So we've got a 15 bar through spindle coolant that's standard. There is the 5-axis auto tuner standard on the high spec one, which is a very unique piece of equipment.
I want to know about that. I'm going to be real techie here. Tell me about that, because I'm sure people listening will go.
5-axis auto tuning is a onboard kinematic check of the machine. It can be run by the operator, real easy to follow walkthrough guides, quite simple and straightforward. It comes as a kit, so you get a sphere. The guide tells you where to place it within the realms of the table. You then bring the probe down in front of it and cycle through what the screen is telling you to do. Once it's done those checks, it can check the volumetric error within the machine and apply a compensation. But what's unique to Okuma is they can check additional items which third-party equipment can't do, such as perpendicularity or straightness of axis. So if it finds there's a slight error on the perpendicularity of an axis, it can apply a mapping in the background. So going forward from that point onwards, if an operator gives a single axis movement, then actually multiple axes will be moving in the background to compensate for that perpendicularity error.
Sounds awfully clever.
It is very clever.
Awfully sophisticated.
And it is a fine-tuning thing. It's not to say, oh, I've had a bump, let's run that to bring it back in line. That's not what it's for. It's about just getting that extra level of accuracy out of the machine.
Because some would argue that they might be able to do that because of the way the machine's built. Without that, would you agree with that, or would you say actually no machine can be as accurate as what you're describing?
Well, we all know zero isn't possible. You can't get to zero. You can get as close to it as you want, and that's what we're trying to achieve with this, is trying to get as close as we can to zero.
Okay, I want to now just mention this control, because there's some things that Okuma are known for, and you've said it to me in the preparation for this podcast, that you are very... you develop everything yourselves in-house. Your automation, a lot of it is your own. Your control systems are your own. This is Okuma, isn't it? What's different with this control system? And people might be thinking, because they'll be watching this and thinking, okay, Richard and NCMT are telling me I can afford this machine. It can go into my machine shop. I'm looking at the barriers to entry here and I'm going, well, one of them might be that control. Can I get to grips with that?
Yeah, the control is, if people are used to FANUC controls, ISO coded controls, then it'd be like a walk in the park for them on this control. Really easy, simple to use, ISO coded programs to look at. You would be like, oh, okay, it's just very similar to a FANUC.
So what does it offer in addition then?
In addition, it can offer a lot more flexibility, so there's a lot more open. You can get in there and do a lot more with it than you could do with FANUC because you're restricted by using a FANUC control. It's a third-party control with a machine in effect, really, whereas this is quite open. It's a very
okay,
open,
so give
open
me an
platform.
example, or give our viewers an example of something they might be able to do on here that will make life easier for them.
So, just as an example, probably a bit too techie, but it's an example. So we've got an API function which allows us to then create our own apps. So we can write our own app that can then talk to the control, update offsets, collect data from the machine, send data to the machine. So there's lots of things we can do with an app. But that's, it depends if the person's techie or not to do that. That's an example of how open source the system
So could
is.
you then get that app on a mobile device and be able to interrogate things using that, or is that...
Depends on the app platform, and if it's connected to the same network as the machine, then in theory, yes.
Okay, because if you're programming a 5-axis, you may use CAM software in a lot of instances, people do even for simple jobs, but this is very easy to not make a mistake. You talk about getting machines out of a line, you don't want to have a bang, you want to make sure that you're programming a part correctly. Is that something that is the fail-safes within here that will make sure that but make it easier for you not to have those issues?
There is fail-safes. Again, there's additional options such as collision avoidance, which is available on some of the Okuma machines. So there's options we can add to that as well as the standard features. But it is that easy to use that there's a function on there called IMAP. IMAP is a basic programming level of something. So a dialog box with features you can populate to do a drilling cycle or deep hole drilling cycle. So there's lots of walkthrough guides for an operator to use to make it easy for them to use.
Okay, and all affordable to general machine shops. This is what we're saying, Richard.
That's the plan. Yeah, this is now on that level where people thought that Okuma maybe were out of their price range, but realistically they're not.
Examples. Tell us about companies that do have these or other Genos machines that okay, we won't mention names, but may have come to you and thought this it's lovely, but I can't afford it. You've got plenty of those?
Yeah, I mean, it's funny you should say that about this one in particular, really. It's this type of machine. We had a customer based in the north. They brought one to replace what I would say is more of a 3-axis vertical machine that was doing multiple operations. They've obviously got lathe work as well, but this coming in-house, the productivity they gained from it warranted them to purchase another machine to bring more work in for them to make a successful company.
Okay, and when making the comparison of this compared to other machines, what do you think drove them to buy an Okuma?
One was realising the price mark of this machine. It was they weren't aware of this type of machine being available for the price it was available at. So that was one, but also the technology on the machine. Everything you get as standard on there, such as the high pressure through spindle coolant, the 5-axis auto tuning, all these additional items they were getting with that price tag, they were gobsmacked.
And what is, on a final point, what is the argument for 5-axis? It's something we've not mentioned during this podcast because we've been focused on the Okuma, on the Genos, but why 5-axis machines? Because again, there'll be people listening and watching that go, well, I've got a 3-axis machine, I've got 4 of them, and I've got a turning centre, and I don't need that extra 2 axes on a machine.
Yeah, I mean,
why do they?
Customers, when they're looking at cycle times, they don't take into account floor time. So floor time is when a part is finished in operation, you might take it off, put it on the floor while you're resetting up for the next operation, then it comes back on. So, okay, they've got cycle times, but they're not taking into account the floor time. That floor time is the bit you can eliminate, because you can hit 5 faces. So instead of having to rotate the part around multiple times to get to all the faces, you might only have to do it twice. So that's one huge saving on a 5-axis.
And the advantage to that is, of course, if you are moving it around a machine shop, you might lose it. It might get put somewhere incorrectly. It might get set wrong. There's all of those factors as well, isn't there?
Yeah, all of those factors plus bottlenecks. It might go to another machine in the factory where that may be doing 3 jobs as opposed to the one that's just done the one. So That's now waiting while the other one's sitting there trying to do the other components.
In your day-to-day activity, I often think we might take it for granted that we see kit like this, we see companies doing things really efficiently and effectively, but we also see companies that really aren't. When you go around, do you still see people making parts in ways you think this type of machine would murder the cycle time on that? You'd get multiple, improvements inside, in throughput and all the rest of it. Is that still common in your day-to-day?
Yeah, definitely. We do see this, and again, it's not just this machine tool type, it's also the mortise type machines, because you'll see where people are doing turning and milling, and you think, well, actually, you can combine that, as long as the productivity works correctly, combine that into the one machine tool, less floor space, more of those machines. So there's a lot of things where people are still trying to build their technology up nowadays in comparison to some.
Now we have to end this now, Richard. But
okay.
I would say before we do, people see Okuma possibly as something that is out of their reach. I'm gonna say here as well, NCMT is known as a business that sells real high value, high levels of technology equipment.
Yep.
But again, people may think that NCMT as a company is someone that they can't talk to because they're not going to be able to supply them what they need within a price range that they need. That's not true either, is it?
No, not at all.
As we've seen here today.
Not at all. It's not true at all. We have a wide range of machines, going from Genos range to high-end, very large machines, double columns, as we mentioned earlier. If the market suits, then we have that available. But NCMT is not just a machine tool agent. We are an engineering company, so we assist customers, we help do turnkey products, so we do look a lot more in detail at what the customer really wants, rather than just putting a machine on the floor.
Okay, brilliant. Richard, it's been a really good insight, not just to Okuma, but of course to the Genos range.
Yep.
Now, there will be videos coming to the MTDCNC website and to our YouTube channel and all the platforms that you'll follow us on, where this machine is going to be in action. We're going to see it in action shortly, cutting. These are affordable, these are available, so you need to talk to NCMT, and we'll put the details in the comments section below as to how you can get hold of them. Thank you very much, Richard. It's been a fascinating insight, not just into Okuma, but NCMT as well.
Thank you.
Thank you.
Yeah.
Thanks for listening to the MTD podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on mtdcnc.com.